Hello, welcome to today's webinar. We are happy to have you with us for this session, A Call to Action on Embodied Carbon. I am Connie Empress, Communications Manager here at New Buildings Institute. This is a Best of Forum webinar highlighting one of the 2019 Getting to Zero Forum sessions and topics given high marks in the Forum follow-up survey. Before we begin, I have a couple of housekeeping things to tell you about. First, you are muted and we cannot hear you. This helps keep the background noise down so that everyone can better hear our speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. We will take a few questions at the end of the presentation. Please ask questions in the same question pane. Please take a moment to answer the survey at the end of the webinar. We do consider your input in the planning of future sessions. If you are seeking AIA credits, this survey is where you will share your AIA number for credit submission. The session is being recorded. All registrants will receive an email tomorrow with links to the recording and slides. If you need a certificate of attendance for your records, it will also be a part of tomorrow's follow-up. We have NBI Director of Projects, Amy Cortez, here with us today to introduce our panel and NBI. Amy, over to you.
Thanks, Connie. Hi, everyone. Thanks so much for being here. I want to start by thanking Autodesk, a Changemaker sponsor of 2019 Getting to Zero Forum, and thanks to our moderator today, Tony Saracino of Autodesk. Today's panel is moderated by Tony. It features our speakers Ann Edminster, Larry Strain, and Marcia Madam. Tony is Autodesk Sustainability Engagement Manager and works across the Autodesk customer base to bring solutions to the architectural engineering construction industry that create impact across all aspects of architecture, engineering, and construction, focusing on low carbon solutions, energy performance, smart cities, and modular construction. Ann Edminster is an international expert on sustainable residential construction and zero net energy. She collaborates with building professionals, utilities, nonprofits, supply chain clients, investors, public agencies, homeowners to create leading edge projects and advocate for zero energy and low carbon building solutions at all scales. Larry Strain is the founding principal at Siegel & Strain Architects. He has spoken on materials, sustainability, and embodied carbon at conferences throughout the country. For the last decade, he has focused on reducing the total carbon footprint of buildings and on building reuse. Marcia Madam is the founding principal at Letty Madam Stacy Architects in San Francisco, winner of the 2017 National AIA Architecture Firm Award. Her work has included the creation of new buildings, rehabilitation of historic buildings, and adapted reuse of existing structures. Before I turn it over to Tony, just a quick word about NBI. Some of you who may not be familiar, we're a national nonprofit organization pushing for better energy and performance and carbon emission reductions in buildings. We work collaboratively with industry market players to promote advanced design practices, innovative technologies, public policies, and programs that improve energy efficiency. We also develop and offer guidance and tools to support the design and construction of energy efficient buildings. We want to make sure you know about the 2021 Getting to Zero Forum. It's again going to be co-hosted by NBI and Rocky Mountain Institute for 2021. We will be in New York, so we're hoping to be in New York City, and we welcome NYSERDA as a local host. And with that, we're excited about this session. So Tony, thanks so much. Over to you.
Thank you, Amy, and hello, everybody. Thanks for joining us today. I want to set the stage that all of our panelists will be talking about. I will join us at the end to talk a little bit more about a tool that launched last November that can help you in solving your embodied carbon challenges. Next slide, please. So on this slide, you see the warming stripes for the globe. This website had launched just before we originally presented this, and I thought it was just very fortuitous timing. before this presentation, and what you see is based on color coding, since 1850 up until 2018, that we're seeing a trend of warming globally. The next slide, please. So we will see growth in the next 30 years that is going to drive creation of more buildings, more products that go into buildings, more consumption of more goods. We're going to see this growth, and about 70% of that growth will live in our cities. In the next slide, please. And what's really important is that there's a movement to cities. About 90% of this new population will live within a day's drive or a day's travel of a city. So it's about, and by 2050, 70% of the population will live in cities. So it's about 7 billion people. So many of these cities required to house these people, this growing, burgeoning population, have yet to be built. And the next slide, please. We're going to need more housing. We're going to need more housing as well as commercial construction. This is based on some research from Statista. This shows some of the multifamily housing constructed that will be needed to be constructed daily to meet this need over the next couple decades. And the next slide, please. However, all of this building comes at a cost. How do we use energy and materials more responsibly? How do we design our buildings better to limit damage to the earth? How do we think about both the operational and the embodied carbon of projects, how much water and how much energy they consume? The next slide, please. But beyond the structures, the buildings, and the materials that will go into them, there will also be a tremendous amount of infrastructure required to connect everything. It's very essential that we continue not to do things business as usual. You see that we're going to be connecting things with grids, with rail, with roads, and all of this construction is going to require a big carbon commitment. And the next slide, please. So when we make building materials and products, they cause greenhouse gas emissions. Activities such as mining, driving trucks, running factories, and combining chemicals result in emissions to the air, earth, and the water. Embodied carbon is the sum impact of all the greenhouse gas emissions attributed to the materials throughout their life cycle, from extraction from the ground through the manufacturing process into the construction process and the maintenance and end-of-life disposal. The next slide, please. Ways that we can start to address carbon reduction are many. If we start at the top, if we want to have 100% carbon reduction, we can build nothing. Well, as we see through the demographic shifts, that's not really, that's not a reality. We can build less. That is something that Marcia will talk about. Think about what's existing and how do we reuse buildings? How do we optimize? We can build smart, and that's what we really need to focus on, is how do we use low carbon materials? How do we streamline that process and then build efficiently? This is all very important, and it kind of goes with the traditional waste hierarchy that many of you may be familiar with. And the next slide. So why this is important? If you look at these two charts, you see in the yellow, you see the embodied carbon of buildings, and that stays pretty stationary. It's a static bar. And the blue is the operational carbon. And you see in the beginning, the operational carbon is small, but as we grow more and more buildings, it gets larger and larger. Ultimately, in the next 3 decades, the operational carbon will be just about even with the embodied carbon. However, the critical time is in the next two decades, or is in the next decade. Within the next 10 years, the embodied carbon will be about 74% of total carbon in the next decade. That is why this is a critical need to address now. This is why this topic has gotten so much attention and why we are spending the time educating you today on it. The next slide, please. Here we see the global carbon dioxide emissions by sector. you can see that building materials, concrete, steel, and aluminum account for approximately 22.7%. And in that, we look at the main materials in there. It's concrete at 11%, steel at about 10, and aluminum at about 1.5%. If we can eliminate or reduce these emissions, it's key to addressing climate change and meeting the Paris Climate Agreement targets. Next slide, please. So I'm going to wrap to talk about two of the materials that we just looked at. We looked at concrete and steel. And the important thing to know is that even if we still use these materials, there's ways to use them more intelligently to reduce their use, and when we do have to use them, to opt for better choices. In concrete, that may mean reducing the amount of cement through uses of admixtures, through uses of smart mix design, through supplemental cementitious materials, which means embedding waste materials into your concrete mix and essentially locking that in for the lifetime of our structures. When we think about steel, using recycled steel, and then how we make the steel. The difference between making steel in a blast oven, a basic oxygen furnace, and an electric arc furnace, one run by coal, one run by hydro or other renewable energies, makes such a difference in that steel. So we have to think about the materials we use. We have to think about how we can use less or fewer of them. And then ultimately, we need to make smart choices in our buildings. And with this, I want to thank you, and I want to turn it over to Larry and Ann for the next section.
Okay, good morning. Thank you. This is Larry. I'm going to kick this off. So Ann and I are going to look at another aspect that often gets overlooked in this discussion of carbon, embodied carbon and operating carbon, and that's the impact on building tall versus building small. It turns out that building tall has a big impact on carbon emissions, both operating and embodied. And so we just wanted to bring that to people's attention and hopefully get more discussion about this. Next slide. So the factors we're going to consider are the time horizon. We have 12 years to solve this problem. So we've got big buildings have a huge impact in that time frame. We're going to look at embodied emissions and operating emissions. And then also, excuse me, I just dropped one of my earbuds. There we go. We're going to look at the transportation and affordability issues and resiliency and livability issues that surround tall buildings. So next slide. New slide. So 11 years left. So this was a year ago. So we really have about 10 years to turn things around and reduce our emissions by about 65% by some estimates. Next slide. So this is what we're going to talk about embodied carbon first. This is what you might expect in a structural, basically a wood building, a concrete frame building, or a steel building. You can see that wood's significantly lower than concrete and steel, and it's sort of what people would normally think, that it's a lower carbon material, so it's going to be a lower impact. But the next slide shows that an even bigger impact is the height of the building, that all of those buildings, that when you get to 15 to 52 story buildings, the carbon jumps way up. And this is on a per square foot or per square meter basis. So it's not just that it's more carbon because the building's bigger, it's more carbon per square foot. Next slide. The other interesting thing that happens with tall buildings is the operating carbon tends to go up. And the first time I noticed this was the CBEX high performance database. There was in 2008, looked at all these high performance buildings, these LEED platinum, very low energy buildings. And they found out that up to 100,000 square feet, the average KBTUs, the EUI was 43. And when you got above 100,000, it jumped to 69. So there's about a 60% increase in operating emissions for larger buildings. Next slide, please. This is a much more recent study in Seattle that was done that basically shows that the high-rise buildings were about 40% higher than mid-rise and 60% higher than low-rise buildings in operating energy. Next slide. And why is this? Well, this was an analysis done of where the energy goes in high-rise and low-rise buildings, and except for heating, every single category is higher in high-rise buildings. Heating probably is lower because there's only 4 sides to a floor. The ceiling and floor don't have any heat loss because there's a floor above and below them, so that's one reason. Cooling goes up, partly because most high-rise buildings are all glass, or what's the point of being high-rise? So they tend to have high cooling loads. Interior equipment goes way up because there's elevators and fans and pumps to move everything around a building that's that tall. So next slide. So the thing you might think, well, tall buildings may be more energy, may use more energy, but they're really efficient because they use land so efficiently. And it's true that they use land efficiently in the sense they use less footprint per unit of building, but they don't necessarily use the building itself more efficiently. If you look at this diagram on the left of the number of elevators that it takes for the Empire State Building just to operate, takes up an immense amount of floor area to do that. The other thing that's often overlooked is that mechanical equipment space is huge in tall buildings, and a trick that developers use, which makes it even worse, is that the mechanical equipment floors aren't counted in your overall height limit. So if you want a taller building, you just make those floors taller and you get to add a lot of height, which then sells for more money. And so people are doing that. So there's actually legislation that would limit the amount of, you can't add a gratuitous height to your mechanical spaces. They've got to be just as much as you need. Next slide. So this one, so why do people want to add height? What's the driving force behind this? Because they cost more to build, costs a fair amount, like an extra 25% to build a high-rise building versus a low-rise building. But the reason is because they sell for even more. There's a huge premium for building high-rise buildings, and you're basically selling that premium and getting a lot more money for the high-rise buildings. The other thing to mention about that is that what that means is that who lives in the high-rise buildings typically are wealthy people, wealthy corporations. And the other interesting thing to note about wealthy people and corporations is they typically use more energy than people that aren't so wealthy. So that it kind of compounds the problem. Next slide. So this is a really recent, these other ones are a little bit older. This is a very recent study by Adrian Smith and Gordon Gill Architecture. And this is in Architecture Magazine's Carbon issue a few months ago. And they have an ebook out called Residensity, which is a carbon analysis of residential densities. And they looked at all these different typologies of housing. And they looked at them, they normalized them all for 2,000 units of housing. So on the right, you see the single family house. That means there's 2,000 houses built. And on the left, there's one mega tall building, and it also has 2,000 units of housing in it. And then super tall, and it gives you the height and everything like this. And what you can see, which is really interesting, is that on the embodied carbon per unit, per square foot, is the highest in the mega tall and the super tall. But the next highest ones are in the urban single family and the suburban single family. So the really tall buildings use a lot of energy, and the really spread out sprawl uses a lot of energy. And the ones in the middle, the courtyard building, actually comes in the lowest for total carbon. So you can see the total carbon on this one. Then the next slide is from the same study, shows the red bar at the bottom is embodied carbon, and the gray bars are operational carbon. And there's one without grid optimization, which is at the top. And then if you have assumed grid optimization, like the grid's getting cleaner, it drops way down. And then on the little yellow bars on the thing are infrastructure carbon. And so you can see that a suburban single family 2,000 units takes a lot of land. So there's a lot of infrastructure tied to that one. So that goes up a little bit. That's why that one's higher. So next slide. So the last thing I wanted to do before I turn it over to Anne to finish up on this is just to mention this. This is going to tie into what Marcia's going to talk about. But we already have a lot of buildings, so they're not very efficient. We can't really afford to replace them all. And reusing and upgrading the buildings we have would result in lower embodied emissions compared to new buildings. And if you improve their efficiency, it would result in lower operating emissions. So the point I wanted to make with this final slide, which is sort of a transition to what Marcia will be talking about, is before you build anything, big or small, consider reuse and efficiency upgrades first. This is a screenshot of a tool that I've been working on that will calculate the total carbon impacts, embodied and operating, for these different scenarios of existing, leaving it as is, a new building, a replacement building, and a retrofit building. And you can see that the retrofit building, when you're retrofitting to even efficient building or even zero net carbon, is by far the least carbon. In fact, it goes negative because you're saving all the emissions that you would have committed. So anyway, that's just a little add-on at the end as a transition. And now I'm going to turn it over to Anne to talk about a couple of other aspects of tall buildings.
Great. So thank you, Larry. That was always inspiring to see that. Just going back to our where we are in our list of topics here, moving on to transportation affordability with one detour along the way. At the next slide, please. So I just wanted to go back to this slide, which Larry showed you, and again point out that the courtyard prototype in the Gordon Gill and Adrian Smith study shows up as factoring in all considerations, operating carbon, embodied carbon, infrastructure, and grid optimization over the building lifespan. This is where the sweet spot is for building height. I did a bunch of research for a book that was published 2 or 3 years ago called The New Carbon Architecture, looking at this topic more broadly, and looked at studies by Adrian Smith and Gordon Gill, as well as a number of other organizations. They all tended to point to this range of somewhere in the mid-rise, low to mid-rise range, not the high-rise, as being the sweet spot. Next slide, please. So moving away from the height issue per se, when I first started socializing this idea with my colleagues, I got a lot of puzzled looks, and most commonly people say, well, we need greater density in order to support mass transit. So having lived in an area with increasing density and good mass transit and increasing transportation congestion, I started to look at this, and what I realized is this premise doesn't actually stand up to scrutiny when you are thinking about a context of an already developed area where land costs and the hurdles to establishing new transportation systems are really tremendous. And so there's this problem of never catching up to the alleged demand. And so we actually end up worsening the situation by increasing vehicle miles traveled and accompanying emissions as we increase population density. So this isn't really a solution. Next slide, please. Meanwhile, the other argument is, well, and we also need more affordable housing, and in order to provide that, it needs to be close to transportation, and it has to be, therefore in densely populated areas. Well, there's another paradox here that, again, when I started to dig into this topic a little bit, I found that in fact, when additional housing is placed in vicinity to new transit or developing transit, then the real estate prices go higher. And as Larry already pointed out, housing in high-rise buildings is not affordable. Quite the contrary. And so this is really an empty argument that if we want to create affordable housing, we certainly don't want it to be high-rise. It's no mistake or accident that almost all of the affordable multifamily housing developments we see also tend to be in the mid-rise range. This is, no one knows better than affordable housing developers what contributes to affordability, and affordability in renting equates to affordability in construction. And so there's a reason these things all cluster into the mid-rise range. Next slide. So my two final points to make are not so much based on research, but on an intuitive gut response. So again, as Larry mentioned, taller buildings tend to be very dominated by glass on their facades. And this is rather problematic in the event of a power outage or other types of resiliency events because it's hard to get out of them. And if you stay in them, there are increasing comfort and even risks to health and life safety related to the loss of power. Next slide, please. And this is my last one, and I think that many of us love cities. I actually love cities, but I find that the experience of being in ultra high-rise zones is really not a pleasant one because of the loss of sun on the street, increased wind tunnel effects. You can be cold in the shade where you needn't be if the sun actually came down, and also just the sense of human scale. Taller buildings also tend to get larger and larger footprints. There's less and less visual relief at the street level to create the variety that as humans we are evolved to respond to. You know, we respond to changes in our environment. Sameness in our environment is very deadening, and we want our cities to be alive. And that's the extent of my comments. So my next slide is the thank you, and then we'll move on to someone else and to just say, let's be more mindful, more vigilant, ask more questions, look at the numbers with your projects, and let's all work on policy solutions that address this issue. Thanks very much.
So I think I'm next up. This is Marcia Madam, and I'm going to provide a case study on an adaptive reuse high performance project in San Francisco. Next slide, please. But first, just to reiterate what Larry and Tony and Ann have mentioned, that retrofit is really a very important key component to addressing the carbon challenge that we're facing with our climate action plans. So this is a program that was launched last September in England about the importance of retrofit, that we need to look at the existing building stock and the embodied carbon that that represents first and foremost when we're looking at our cities and our existing communities. Next, please. Just so I wouldn't be left out, I wanted to have a graph too. So this one is actually a similar information to what Larry pointed out, just visually displayed in a slightly different way. This shows 3 different scenarios: a standard code new construction project, a zero net energy new construction project, and then a net positive retrofit of an existing building and reuse. So you can see that the represented in the materials and the embodied construction materials for the first 8 to 10 years, the 3 lines are quite different, with the retrofit being the best case. But then it's interesting with the operations of the buildings for the next 20 to 50 years, you can see the importance of doing a high performance and a building retrofit in really addressing the carbon challenges that we are facing. So next slide, please. So my case study is the retrofit of the historic Army Pier at Fort Mason for the San Francisco Art Institute. It's located at the edge of the San Francisco Bay, and the building was constructed in 1909 and used through 4 wars as an Army base, and then transferred over to a cultural art center, the Fort Mason Art Center, in the 1970s. So next slide, please. Our office had been working with Fort Mason and with the National Park Service, who runs the Golden Gate National Recreation Area, a national park that encompasses Fort Mason, as well as other sites along the bay that were transferred from the Army with the base closure process. And the San Francisco Art Institute wanted to expand their campus and saw that Pier 2, which is the middle pier, the middle finger pier in this photograph, was an ideal candidate for a new graduate program. If you go to the next slide, it's a easy 20-25 minute walk from their historic main campus located on Russian Hill. And there you can see the plan of the Fort Mason Center. Next slide, please. This building has a really rich history. As I mentioned, it was an active Army base, and it supplied the entire Pacific Theater during World War II. You can see in the lower left image, this is where all the Army personnel and supplies left for the Pacific Theater. And it had been a really important historic landmark. Next slide, please. And its historic use, here you can see during World War II, the supplies that were housed inside of Pier 2. This building is an historic landmark because of its importance for military history. And so our charge as a historic tax credit project, working with the Art Institute, was to come up with a strategy to add program area, but still keep the integrity of this important industrial warehouse structure. And so our strategy, next slide please, was to create a series of floating mezzanines and to carefully insert new program uses into this really beautiful, light-filled, historic industrial space. And as a tax credit project, and I want to make a pitch here for the importance of the Federal Historic Tax Program, it was really essential part of the financing for this project. And it is a great program, but takes a great amount of collaboration and thought, working with the State Historic Preservation Office and also the Washington, D.C. Historic Tax Credit staff with the National Park Service. But working together, we came up with a strategy that did create this incredible working space for artists for the San Francisco Art Institute. Next, please. So here are the floor plans. Just quickly, you can see on the top floor plan at the top of the page was the space when we, after the initial retrofit of the shed, it was just an open exhibition space. And so you can see in the plans below, the blue areas are the individual artist studio spaces. There's a gray box media theater, a maker space, seminar rooms, etc. So all of these spaces were carefully inserted. Next slide, please. Inserted into this historic volume. And another important component of this was the integration of sustainable building strategies. And as you can see in this axonometric view, we were able to install a 255 kilowatt photovoltaic solar panel system on the roof, which generates 100% of the electrical needs for this building and goes back into the grid. And then another important point that I'll go into more detail is the addressing of the floor slab and the heating system by incorporating a radiant floor slab throughout this 500-foot long pier. Next slide. So renovation is exciting and challenging. Here it is in its the middle of construction. This building had been not maintained over decades, and so the concrete was falling. The steel with the salt air of the San Francisco Bay had eroded significant portions of the steel structure. And so our first important move was to seismically upgrade this really lovely industrial shed to make sure that it was going to survive it being in a high earthquake zone in San Francisco. We needed to protect the structure. You can also see the historic train tracks. Because this is a landmark structure, these train tracks, which were embedded in the slab, were deemed to be part of the historic fabric, and so we needed to maintain them. Next. So this is a picture of the completed first phase when we did this structural seismic upgrade. You can see the new steel kickers, and then we installed that radiant floor slab to provide a very highly efficient and comfortable heating solution. And you can see, if you look closely, the crossing of the train tracks. We kept that marker in the design of the floor so that that piece of history could be read by the public as they came into the space. Next, please. And after the interior renovation for the San Francisco Art Institute, you can see how the floating slabs of the mezzanines, the central open atrium space, and the amount of glazing all the way through the pier has kept the integrity of this industrial historic building and has become a very lively center for the arts. Next, please. So this is a section diagram that just highlights some of the strategies that we used. Again, you can see the 100% renewable energy with the photovoltaic system on the roof. We were able to meet the AIA 2030 commitment with an 83% reduction in energy use for a building of this type. And we've calculated using the Athena calculator that this is a 75% reduction in embodied energy and carbon because of the building reuse. And I'm going to spend a little bit of time talking about the radiant floor slab because it was an interesting process with our client. If you could go to the next slide, just to highlight this building section. It is almost 100 feet long, spanning across the San Francisco Bay. And so you can imagine that we wanted to make sure that we had a good thermal separation between our interior and the bay. So if you go to the next slide, the ideal solution was to put in a radiant slab. It accomplished multiple challenges. It encapsulated the whatever toxics were left from all the warehouse activities over the decades. We were able to put in a new topping slab to even out the floor area. This did have quite a significant slope, and it was just an asphalt warehouse floor when we started the project. But it was really important for us to include a layer of insulation to create that thermal separation. Next slide, please. So here you can see a quick detail that shows the existing concrete deck of the pier. We put in a vapor barrier and that important layer of rigid insulation, and then the radiant heating in the topping slab. Next, please. We did an analysis with using the Therm program, which is a free program, just to understand what that rigid insulation did to help us convince our client, which is a nonprofit educational client, you know, the value of expending that first capital for the long-term benefit of the comfort of the inhabitants of the building. Next slide, please. So here, this was our argument that if you did put in that existing rigid insulation, that you were able to maintain 74 degrees inside, while the San Francisco Bay below would be at 40 degrees. The slab, under slab, would be at 40 degrees. And if you did not put that rigid insulation in on that measured day, we would have a 48-degree temperature, which you would then have to spend energy for the rest of the time you are using the building to make that a comfortable space. So the cost benefit analysis was very clear to our client, and we were able to put in that very important rigid insulation into this radiant topping slab. Next slide, please. So one other challenge that we faced is acoustic comfort, which was really important. How to make a acoustically comfortable space for the artists and the people who use this building in this very large, tall, hard-surfaced industrial shed. And so we came up with some very low-cost, efficient strategies. On the roof, we just did a simple grid of acoustic tile panels. You can see in the upper part of the photograph. Just paint it out, you really don't notice it. That was an approved solution with the National Park Service. because of the landmark status. And then you can see the floating mezzanine slabs, which were held away from the concrete perimeter walls, both for seismic separation and also just to have them read as separate structures so that you could still see the full height of the exterior walls. At those new floating mezzanines, we used an Epicor acoustical integrated deck, both to keep the slab as thin as possible and to provide acoustic treatment. If you go to the next slide, you can see the underside of that floating mezzanine slab has acoustical treatment and perforations integrated into the structural deck. Next slide, please. A little bit about the energy performance. This 255 kilowatt photovoltaic array on both sides of the pier was a highly controversial item. We worked closely with the National Park Service, our California State Historic Preservation Office, and the Washington, D.C. National Park Service office rejected this initially in our tax credit application, saying that it was not appropriate for a landmark building. The State Historic Preservation Office and our office made a plea and got that ruling overturned. And it's now a very visible, great example viewed by everybody going across the Golden Gate about the power of renewable energy. Next, please. Next. But I just want to end on a few slides of just how this space has been brought to life for a new use for the next 100 years. Next, please. It's taken on a life of its very successful life for the last 2 years with wonderful events and gallery exhibits and students doing fantastic work. Next, please. This is a young woman whose work was just amazing, and she said that the space had allowed her to work at a scale and in a way that she had never been able to do before. Next, please. So it has been a really exciting time over the last couple of years, but unfortunately, some of you may have read in the New York Times and other media outlets that the San Francisco Art Institute, founded in 1871, one of the oldest fine art institutes in America, is ceasing operation, partially because of the current pandemic. But we're hoping that it will find a new partnership and reopen after this current global crisis is done. Next, please. But I think the important story here is that through adaptive reuse, high performance retrofits, we can take not only these important embodied carbon resources, but also these important embodied cultural resources, preserve them, give them a new life, have them integrated into our community for the next 100 years. So I look forward to seeing this building reopen in the near future, and look forward to it continuing to be a really important part of our community and this national park at the Golden Gate and the San Francisco Bay. So that is my part. I think I give it back to Tony.
Yes, thank you, Marcia. And thanks, Anne and Larry. I think if we heard many things, just to kind of cap it off before we close out with a few minutes from me, is that it's important what you build. It's important the size of what you build. It's important to think about many things. Think about what's already existing. Here in the global north, we're blessed that a lot of the buildings we have are still here. But when we think about places where the buildings don't exist, they might not have the opportunities to reuse the buildings. So then we have to be smart about how we build, how we create density, how we plan, how we think about the urban environment. So what I want to talk about in closing for a few minutes is the embodied carbon in construction calculator. This is something that launched this past November. It was launched at Greenbuild, and you can keep going with these slides. So think about it as a calculator. A calculator does a math. It takes the materials quantities. If you could just click back really quick, takes the materials quantities. We're flying. I don't know. Back one more. Thank you. Takes the material quantity of what's in a building, be it the enclosure, the structure, the steel, the concrete, multiplies that by a environmental product declaration or an EPD, and then tells you the embodied carbon in a building. So let's talk about where we get that material quantity. In the next slide, you can click right through. We can take that material quantity. It can come from the BIM model. If you're doing building information, it can come from construction. You can keep clicking, 2 clicks here. It can come from a BIM model that just imports your structure. It can come from something like Tally, where you're doing life cycle analysis. Next slide, please. So here you see what can come, what can come from the tool. The carbon smart estimating. So you look at the materials where it's produced. It gives you a range of what's achievable, what's conservative, what's best in class. You can start to see the variance in the emissions based on your material. You can see the conservative estimate of what you can save, what's achievable in the 20th percentile, all the way down to 0 embodied carbon in your materials. And the next slide, please. So what this allows, it allows you to quickly understand, what the range is of a material, and it lets you find and compare different environmental product declarations of your materials into your building product profile. So you can start to sort them, start to look at them based on their global warming potential. Next slide, and you can click this twice, Connie. So you can sort by, as I said, the global warming potential to find the lowest, and then you can see the details and automatically download the environmental product declaration that's there. And that's really important because the documentation of a lot of this is essential, and then going to the right manufacturer to find out what you need. And the next slide, please. So what's really fascinating is how it's been driving the industry since it's launched. Here you see 3 different producers. You see kind of the average of everyone, and then you see your competition. So now you can walk up to a concrete producer and you can ask them, hey, I see that you don't produce EPDs. We'd really like to work with you. Can we do this? And we're starting to see this both across steel and concrete industries, but also elsewhere. And the next slide, please. So we'll see if this plays. So this is the really quick video showing the import of a BIM model into this. And what it does is it lets you leverage the embodied carbon calculator, but also then use the 3D model as a viewer of where you have potential based on your design intent, based on the materials you selected, to visualize that and see where you have potential to do better, where things are red, where you've really hit it with a great choice or great selection in green and otherwise. The next slide, please. This gives us the ability to specify and procure carbon smart materials. And that's probably the most important thing of this tool. I'm going to show you a little bit of the uptake in use in the next slide. This tool, as I said, was launched at Greenbuild this past November. And from that date to today, it's reached over 5,000 users. And if you go to the next slide, you see the breakdown of the users. The people that are looking at this are all over the stated profession of the building industry, from architects, structural and civil engineers, people that are performing life cycle assessments, all the way into the construction and manufacturing spaces. And what is really interesting about this, and if you can go to the next and final slide, is that this is a free tool. You can access it at buildingtransparency.org. But it started as a partnership. It was started by Skanska USA when they were working on the Microsoft Campus project. With funding and support from the Charles Pankow Foundation and Interface, then Autodesk was able to come on as a technology partner to help tie this all together in a certain way. It's been funded from the industry. and no one owns it. That said, it was made to solve these problems that we've addressed in this webinar quickly, efficiently, and otherwise. And you see what happens when an industry comes together and people work towards a common goal. So that's just a high level. Please go to buildingtransparency.org if you want to use the tool or learn more about it. And that concludes it. And we're happy to take questions and answers. So thank you very much for your time and sticking through this with all of us.
Great. Thank you so much. Really great information there. I want to encourage people that if they do have questions, they can use the chat function to send them into the group, and we can help make sure that they get answered. But at this point, though, I am not seeing any questions. You guys are must have been very crystal clear.
I have the question pane open, and we do have a few questions. I just wanted to go over our little Getting to Zero resource hub. We are promoting right now. It has an embodied carbon section that will help you with resources that you might need in tackling your embodied carbon. So let's see here. Okay, so I just wanted to quick note, when you guys get your follow-up email tomorrow and you get your certificate, we only use the AIA credits for our sessions, and anything else can be self-reported, from what I understand, by using the certificate that will come with your follow-up email. So just to clarify that. You mentioned a carbon calculator. Can you tell us more about the input assumptions and when it'll be available?
Was that for me? Is Larry?
That is for you, Larry.
Yeah. So we're working on it now. We have a really rough beta version now. We're hoping to have a better still beta version out in a couple of months. We're still working on some of the bugs in the system. But the assumptions are based on a couple things. The embodied carbon assumptions were based roughly on the embodied carbon benchmarking study a few years ago that the Carbon Leadership Forum did. And we sort of picked sort of average numbers for large buildings, you know, concrete and steel large buildings, and then a different number for just a light wood frame house type building. And then we picked a different number for just an interior retrofit of an existing space. We sort of have these three different assumptions for embodied carbon. One of the things in the future is to expand those to a lot more nuanced selections. So it wouldn't just be those three, but that's where we started with. And then the operational emissions are taken from, based on originally the CBEX database from 2012, which looks at building types and EUIs for different building types. And then we apply for new construction, we apply the 2030 goals. So a new efficient building would be 80% less than that CBEX base building. And a efficient retrofit would be 50% less. And then we also have a zero net carbon option. If you're making your building to be all electric, running off of renewables, it's a zero carbon emission building. And those are plugged in to the calculator. When you enter your building, you also enter your state and your climate zone. The state has the average grid emissions by state. The climate zone gives you operating energy. Basically it changes as you go around by different climate zone and by different state. And so it's pretty good in terms of the operational emissions. We have obviously a lot less online resources for embodied. So the idea is over the next few months is to continue to develop it and offer more nuanced choices for people so they don't just have these things. But just based on those initial embodied emissions and operational emissions, which are kind of tied to national databases, it gives you a pretty good rough idea of the value of reuse or not. In some cases, it's better to replace the building. So we're pretty excited about the potential, and there's a lot of work still to do on it. And so you're welcome to, if our contact information is available, you're welcome to stay in touch with me. I'm trying to pull together people to continue working on it and try and find some funding as well.
Okay. We have somebody who would like to know, are embodied carbon policies, codes, or incentives being offered? If so, where? Kind of a blanket for everybody.
Yeah, I mean, I can speak a little bit to that. Again, this is Larry, that there are some buy clean initiatives happening in different states. California and Washington and other states are looking at some buy clean, which would basically incorporate some materials and some rewards or instructions to state agencies to buy lower carbon materials. It hasn't gone very far. It needs to go a lot farther with it. You're starting to get it incorporated into some of the rating systems as well. So I think what we're seeing is just the beginning of this huge upsurge in interest and focus on embodied carbon, which is so important for new construction to bring that number down. But it's lagging. So I would say that there's a lot more work to be done in that case. Does anybody else have anything to add to that one?
I have a quick comment. Oh, sorry, Tony. I just have a quick comment.
Go ahead, Marcia.
I just want to let everybody know that they should check out the information about the Zero Carbon Code, which here in California, we're busy trying to get that a part of the next code cycle here in California. So I urge you to look into that and work with your local municipalities and state agencies to try to get that zero code included in your area. That's really, really important because we know that policy and law is really how big change happens. And then I think the other thing I'd like to highlight is here in the Bay Area, the movement over the last year towards all electric in requirements by municipalities throughout California. It's been staggering how quick that is developing. So here in the Bay Area, you cannot have fossil fuels brought to new construction sites for commercial buildings in Berkeley and San Francisco and other municipalities around the Bay and throughout California. So again, these are really important policy changes that are going to have really significant positive impact for climate action.
And this is Ann.
I just want to I'm just going to add really quick one thing that is very interesting to see coming out of France. Lafarge Holcim, which is a material supplier, they make a lot of concrete. It's a big multinational corporation, has started essentially kind of an embodied carbon project for roads because roads are such a huge thing. So we're starting to see this in infrastructure. It's called ORIS, O-R-I-S. I recommend people take a look at it. Again, from Lafarge, L-A-F-A-R-G-E Holcim, H-O-L-C-I-M. So it's nice to see it moving beyond buildings too in some of the conversation. Sorry, Ann.
No, that's all right. I was just going to add too that there's a pretty active discussion about policy, among other things, on the Embodied Carbon Network, which is run by the Carbon Leadership Forum. So I would encourage anyone who wants to know more about policy and how that scene is rapidly evolving to join up with the Embodied Carbon Network. And again, you can learn about that by going to the Carbon Leadership Forum website. Just put that name into a browser and you'll find it.
Okay, it looks like we are up for time today. Thank you so much to our panel. Thank you to my colleague Amy, who is helping me out today on here. And thank you all for joining us. We're really happy to share this information with you today.
All right, thanks everyone.
Yeah.
Thank you. Be well. Good health to everyone.
Thank you.
Yeah.
Take care, everyone. Bye-bye.
Bye.